Welcome to the first lesson in 4th grade. Chapter 1, Lesson 1 is talking about place value. Now, in order for us to understand place value, we really need to look at our numbers and understand what each of those digits mean. So let's take a look at a number. The first number that we're going to look at is the number 25. That's a pretty small number, but let's just take a look. Now, when we look at the number 25, we say 25, but what does that mean? What does our 2 mean and what does our 5 mean? Our 2 stands for 2 tens. Our 2 is in the tens place, so this is 2 tens. And our 5 stands for 5 ones. So another way that we could say this number would be 2 tens, 5 ones, 25. Let's take a look at a bigger number and see if we can break it down as well. Okay, now this number is a little bit bigger, but I want you to see and hear how we break this number down. We're starting with our 6, and we would call this number 673. Now, when we say 600, it already tells us what the value of that digit is. That's 6 hundredths. Now, when we say 70, what does 70 equal? That's what we have to understand. 70 is equivalent to 7 tens. And then we have our 3, which is in the ones place, and so this is 3 ones. So another way that we can say this number would be 6 hundredths, 7 tens, 3 ones, and that breaks it down by place value. Now in 4th grade, we're going to be looking at numbers that are quite a bit bigger than this number, and we really need to think about this same philosophy, breaking down each number by its place value and identifying what that means. So let's take a look at a bigger number. Here we have the number 52,081. And notice when I say 1,000, that's where we see this comma right here. 52,081. This comma breaks up our periods. Our periods are the separation between those ones places, those thousands places, those millions places. And whenever we say those numbers, thousands or millions, that's when we're going to see our comma. And we're going to go back to that again and again and again throughout the entire school year. So I want you to remember that. Now let's break this number down by its place value. When we're looking at our 5 is in the 10,000s place. So we have 5 10,000s. Then we have 2 is in our thousands place, so we have 2,000s. We don't have anything in our hundreds place, so we can skip our hundreds place and we go straight to our tens place. And we would say this piece right here, 81, but this number right here, our 8, represents 80, and 80 is equivalent to or equal to 8 tens. And then we have our last place, which is our ones place, and we have 1, 1. So another way that we could say this number would be 5 10,000s, 2 thousands, 8 tens, 1, 1. But when we say it all together, we would say 52,081. Notice, I don't say and anywhere when I say that number. When we say and, that indicates that there's a decimal. And would come after that 1, and because there's no decimal in this number, I'm not going to use the word and. I only use the word and when I have a decimal. So I want you to start working to get rid of that habit, and we're not going to say the word and, we're just going to read the whole number. 52,000, and notice again, when I say 1,000, there's my comma, 52,081. All right. Let's take a look at breaking some of these numbers down and identifying the value of our digits. Let's start with the number 10. If I have the number 10, what does that mean? Well, that means we have 1 10. That's pretty obvious. But what does that mean in terms of ones? How many ones do I have? Well, a lot of you have filled out 10 frames before in your life, especially when you were in 2nd grade, maybe even in 1st grade. Let's take a look at a tens frame. So here's our tens frame, and we know that when we get to 10, all of our tens frame squares are filled in. So this is equivalent to 10. So 110 or the number 10, is equivalent to 10 ones. I have all of those little ones, all those little red dots in here, those indicate a 1. And I have 10 of them, so that's equivalent to 10 ones. That's pretty simple. But when we get to bigger numbers, it gets a little bit more confusing. So let's take a look. Okay, here I have the number 30, and I want to see how many tens is that, and how many ones is that equal to. Now, I could draw my tens frames, and if I did that, I would have to have 3 full tens frames in order to equal 30. So if I drew a picture, I could really see, okay, well, I have how many tens? I have 1 10, 2 tens, 3 tens. And if I were to count up all of those ones, all of those little red dots, I would see I have 30 ones. Another way that I can do this is by looking at the tens place. So here's my ones place. And my second place is my tens place. And there's a 3. So this 3 right here is in my tens place, and that indicates that I have 3 tens. It also shows me, if I look at the whole number, that I have 30 ones. Okay, now, why does this matter? Let's take a look at a number, and we're going to identify the value of a single digit within that number. Okay, we have the number 2,304, and we have the number 16,532. And what I want to do is compare the value of these 3's. In order for me to do that, I need to understand what these 3's represent. If I'm going to look at the first number first, so I'm going to start right here. I have 2,304, and I'm just focusing on the 3. I need to know my place values. I have my ones place, my tens place, and my 3 right here is in my hundreds place. I have 3 hundreds, or I could write this as 3 hundreds. I could write it as number form or word form, either works. So I have 300 or 3 hundreds, and when I look at my next number, 16,532, my 3 is in my tens place, ones, tens. So this 3 represents 30 or 3 tens because it's in my tens place. Now, I'm going to be asked to compare these two values, my 3 hundreds or my 3 tens. Which is larger? Well, my 3 in 2,304 falls in my hundreds place. My 3 in 16,532 falls in my tens place. So, 300 is larger than 30. I think that's pretty self-explanatory. Pretty sure you all got that part. But why? And what does that look like? And how much larger? Let's take a look at how much larger that 3 and 300 is than the 3 and 30. I want you to take a second, and I want you to write down an observation that you make between the 3 and 300 and the 3 and 30. Do that now. Some of you may have said, oh look, there's an extra 0 here in 300, and there's only 1 0 in 30, so I see another 0. Okay, you're right. Some of you had said, well, obviously 300 is bigger than 30. I can just see that by looking at the numbers. You're right as well. But why does this 0 matter? What does this 0 represent? When we're looking at these numbers, 300 versus 30, how do we get from one to the other? How would we go from 300 down to 30? What type of properties would we have to do? What would we have to do to 30 to make it 300? There's a few different things that we can do. We can multiply or we can divide in order to get from 300 to 30 or 30 to 300. Let's look at multiplication. That's generally the easier property than division is. If we were to go from 30 to 300, some of you might have said we could add. You're right, we could have added 30 plus 270 would equal 300, but that's not really what we're going to focus on. We're really going to focus on the multiplication or the division. So if we're going from 30 to 300, what would we have to multiply times? I want you to take a second and answer in the box provided. Okay, well, I hope you answered 10. We'd have to multiply times 10. When we multiply anything times 10, we're going to be adding a 0. Now, here's why. Let's take a look. Okay, we have 3 times 10. Let's make a picture to see what that looks like. We have 3 10 times. We can draw an array to see that 3 tenths times, and if we added all of those little dots up, or we skip counted by 3, we would get to 30. Now notice we went from 3 to 30, or 3 tenths. We added that 0. The same would fall true if we multiplied any number times 10, we're adding that 0. So if we go back and look, and we're looking at the value of those digits and which is bigger and how much bigger, 300 and 30. 300 is 10 times the value of 30. It's 10 times. We're multiplying times 10. We're adding that 0. Now, if we look at the numbers as a whole, and we were to compare the value of that digit, and we want to know which 3 is larger and how much larger, we would say something along the lines of the value of the 3 in 2,304, because I'm focusing on that 3, is 10 times the value of the 3 in 16,532. Now, don't let it confuse you, because 16,532, that's a bigger number. We can all agree that 16,532 is larger than 2,304. But we're focusing on the value of that 3. And that 3 in 2,304 is larger than the 3 in 16,532, or 3 tenths. Okay, we're going to do a little review of everything we've talked about. So let's take a look at this number, 5,375. And I want to know, what is the value of that 3? What does it represent? How much is that 3 worth? If I were to take that number apart and break it apart by each of those digits, how would I write that 3? I want you to figure that out now. Okay, we would write that 3. That 3, the value of it would be 3 hundredths. We could also write this as 300. That's the value of that 3. That's how much it's worth. Let's take a look at another one. We have 19,752, and I want to know, what's the value of that 9? Write it now. What's the value of that 9? That 9 is equal to 9 thousandths, or 9,000. Okay, let's do one more. 537,216, and what's the value of that 5? The value of the 5 is 500,000, or 500 thousands. Whether you write it in word form or in number form is fine. Okay, now let's compare some values and see if you can tell me which number is greater than which and by how much. Okay, here we have 2,000 and 200, and we have to fill in this little riddle. So the value of the 2 in blank is blank times the value of the 2 in blank. Our first objective is to figure out which value of the 2 is greater. So is this value or this value of that 2 greater? Because we're just looking at that 2 and that number and that's it doesn't take a lot of work for us to figure out which one's greater. So the value of the 2 in 2,000 is blank times the value of the 2 in 200. And now we just need to identify, well, how much bigger is it? We talked about before when we were looking at different numbers that when we're just adding one zero, we're multiplying times 10. So let's look at our zeros. We have 1, 2, 3 zeros here in 2,000, and we have 1, 2 zeros in 200. In order to go from 200 to 2,000, we have to add one more zero, which means we need to multiply times 10. So the value of the 2 in 2,000 is 10 times the value of the 2 in 200. I want you to do one by yourself. Okay, here we're looking at the number 67,906 and 70,966, and we're focusing on the value of the 7. I want you to fill in this riddle. The value of the 7 in blank is blank times the value of the 7 in blank. Do that now. Okay, let's take a look. The value of the 7, and we want to focus on that value. So I'm going to go up here and I'm going to look at my value. This 7 is worth 70,000. This 7 right here is only worth 7,000. So because I'm looking at that value, this 7 in my second number is worth more than the 7 in my first number. So because that second number, the value of the 7 is 70,000, that's the first number I'm going to write. I'm always going to write my bigger value first. Not my bigger number always, but my bigger value. So that number is going to go in first. 70,966. The value of the 7 in 70,966 is blank times the value of the 7 in 67,906. And now I just need to figure out how many times larger is it. Well, I'm looking at the values that I wrote. Here I have 70,000 in my second number. In my first number, I just have 7,000. So I need to add 1 0, which means I need to multiply times 10. So the value of the 7 in 70,966 is 10 times the value of the 7 in 67,906. So today we focused on two concepts. We focused on the concept of identifying values in numbers and what they mean, and then comparing values within numbers. That's our lesson for today. See you tomorrow.